Hello again, math friends. Welcome to this episode. Today we're going to look at adding and subtracting rational expressions. We need to remember that a rational expression is a fraction. And in order to add or subtract fractions, the denominators must be the same. This means that you must get a common denominator. And really, finding the least common denominator will decrease the chance that you'll have to reduce the fraction at the end. So if you want to save yourself some work, find the least common denominator instead of just a common denominator. So let's do a little bit of review. We want to know what the least common denominator would be for each of these. So we know that the smallest number that both 4 and 3 will go into is 12. So our least common denominator is 12. In this example, our least common denominator is 20. Because the smallest number that both 5 and 20 will go into is 20 itself. Now down here we have a little bit different issue. First of all, let's look at 12 and factor it. 12 is 2 times 6, and 6 is 2 times 3. So 12 is really 2 squared times 3. 18 is 2 times 9, and 9 is 3 times 3, so we have 2 times 3 squared. Another way of thinking about the least common denominator is looking at the factors of each denominator and making sure that all of the factors from each denominator are in the common denominator. So if I start with 12, I need 2 squared and 3. So I know that my least common denominator is going to at least have 2 squared times 3 in it. Then we go to 18. We need a 2, but we already have a 2. And we need a 3 squared. Well, we have 3, so I need a 3 squared. So the factors of 18, 2 squared and times 3, are inside the least common denominator. And our factors for 18, 2 times 3 squared, those factors are inside of this least common denominator. So this gives us 4 times 9, which is 36. We do exactly the same thing when we're dealing with rational expressions. And we want to add these two together. So the first thing we must do is find the least common denominator. And in this case, the least common denominator is going to be x times y. The only factor of x is x. The only factor of y is y. X is in here, y is in here. That's our least common denominator. Then we look at this first fraction and we talk about what did we do to this x to get xy. Well, we multiplied by y. If we do that on the bottom, we must do that on the top of the fraction, and that gives us 1y at the top. If I were to take this fraction and reduce it, the y's would divide out and I'd have 1 over x, which was our starting fraction. For the second fraction, we need to look at what did we do to y to turn it into xy. Well, we multiplied by x. If we do that on the bottom of the fraction, we must do that on the top of the fraction. And so we get 2x. Now our denominators are the same. So that becomes the denominator of the answer, and we simply add the stuff on the top And so we typically put our variables in alphabetical order when we write an expression. So I'm going to write this as 2x plus y. These x's cannot divide out, the y's cannot divide out, because this is a binomial. This 2x is being added to the y, so those things are locked together. We cannot divide out an x and a y. If this had been 2x times y, then we could have been dividing out some of the factors. All right, let's take a look at another one. This time our denominator is an actual expression. So I have this factor and this factor. So my factors are x minus 1 and x plus 1. That becomes my least common denominator. Then I look at what did I do to x minus 1 to turn it into x minus 1 times x plus 1. Well, I multiplied the bottom by this x plus 1 factor, so I must do the same thing on the top. Over here, the x plus 1, I multiplied it by x minus 1 to get this common denominator, so I need to take the top and multiply it by x minus 1. Now we can go ahead and simplify this first by multiplying out the 3, distributing it over the x plus 1. We get 3x plus 3 over x minus 1 times x plus 1 plus 2x minus 2 over x minus 1 times x plus 1. So now we have one fraction. Denominator is x minus 1 times x plus 1. And on the top, we simply add all of these terms together. 3x plus 3 plus 2x minus 2. This gives us 5x plus 1 over x minus 1 times x plus 1. So do you see how we found our least common denominator? Then we took our fraction and said, what do we multiply the bottom by in our original fraction to get the new fraction? Whatever we do on the bottom, we do on the top. And we repeat that process for any of the other fractions that are in our expression. Okay, here we're going to need to do a little bit of factoring first. So I know that x minus 9 is the difference of 2 squares. If you need help with difference of 2 squares, watch my video on the difference of 2 squares. It's very helpful. And this is unchanged. So now my common denominator has to have these two factors in it. So that's going to be x minus 3 times x plus 3. And the numerator doesn't change because the denominator is the same. But in this fraction, we have the x minus 3 term, but we need the x plus 3 term. So this becomes our common denominator. I need to look at what did I do to this to turn it into this. Well, I multiplied by x plus 3 on the bottom. I need to multiply by x plus 3 on the top. And there was an x already there. So I need to work on this second fraction. So let's leave this fraction the same. This becomes x squared plus 3x over x minus 3 times x plus 3. Now I've got an issue here because I'm subtracting. And so since I'm subtracting this fraction, that negative has to be distributed over everything on the top. So this really becomes x plus 2 times let's see, x minus 3x plus 3 plus a negative 1 times x squared plus 3x over x minus 3x plus 3. Now distribute that negative 1, and I'm going to go ahead and write this as one fraction. And this becomes x plus 2. This is minus x squared minus 3x. Combine my like terms. We get a negative x squared. A negative 3x and a positive x is a negative 2x. And we have a positive 2. And I really don't like that negative in front of the x squared, so I'm going to factor that out just for this to be cleaner. So I've got to divide everything by a negative 1 when I factor it out. So this becomes plus 2x minus 2 all over x minus 3 times x plus 3. And I would need to look to see if this will factor. I know that it will not, because that trinomial is prime, and so this ends up being my final answer. Okay. All right, let's step it up just a little bit. This time we have two expressions that are different, and we are subtracting this second fraction. So my common denominator, my least common denominator, is x minus 4 times x plus 5. And x minus 4 times x plus 5. I already have an x plus 5 on the top, but I'm multiplying by another x plus 5. And here I have an x plus 2, and I took this and multiplied by x minus 4 to turn it into this, so I need to multiply the top by x minus 4. At this point, it's a good idea to just double check. If these divided out, I would have x plus 5 over x minus 4, which is my original fraction. On my second fraction, if I divide out the x minus 4s, I'm left with x plus 2 over x plus 5, which is my original fraction. So what I need to do now is use FOIL method and multiply out those two parentheses. FOIL method is also distributive property. X times x, x times 5, 5 times x, 5 times 5. So I get x squared plus 10x, 5x and 5x, plus 25, 5 times 5, minus, on the top here, x times x is x squared, negative 4x and positive 2x is negative 2x, and 2 times negative 4 is negative 8. And this is over x minus 4 times x plus 5. Now I need to remember, since I'm subtracting, that negative has to be distributed over each term. So I'm going to write this as one fraction. And let's see what our terms are going to be. We have an x squared plus 10x plus 25, and this is minus x squared plus 2x, and this is plus 8. So now the x squareds add out. 10x and 2x is 12x. 25 plus 8 is going to be 33. The top will factor. We can factor a 3 out of both of those, so I'm going to factor the 3 out, and I get 4x plus 11 and x minus 4 times x plus 5 on the bottom. We have nothing that will divide out, so that ends up being our final answer. Wow, look at here. First thing we're going to need to do is take each of these trinomials and factor them. So I know that trinomial factors into two binomials. I need x and x. Factors of 3 and 1. I need a negative 4x, so if I make both of these negative, I get negative x, negative 3x is negative 4x, and negative 3 times negative 1 gives me the positive 3 when I distribute that back out. Let's do the same for the second denominator. This time we have factors of 2, and we need a negative 3, so again that's going to be negative, that's going to be negative. We get negative x, and negative 2x gives me my negative 3x in the middle, and negative 2 times negative 1 is positive 2. Now for my common denominator, I need an x minus 3 term. I need an x minus 1 term. I need an x minus 2 term. I need an x minus 1 term. I already have it, so I don't need to put it in there again. So this becomes my least common denominator. Then I need to look at what did I do to this fraction, the denominator. What did I do to this to turn it into this? Well, there's an x minus 2 there, so I multiplied the bottom by x minus 2, so I need to multiply the top by x minus 2. On the second fraction, we have an x minus 2 and an x minus 1, so we multiplied the bottom by x minus 3. I multiply the top by x minus 3. Up here we get 4x minus 8 when we distribute that 4. And x minus 2. Plus here we get 5x minus 15. On the bottom, x minus 3, x minus 1, x minus 2. Now I'm going to write this as one fraction. My denominator, x minus 3 times x minus 1 times x minus 2. And 4x plus 5x is 9x. Negative 8 and negative 15 is negative 23. And that will not reduce any further. All right. Last one. Let's take a look at this one. So I need to factor. I have to be careful that I'm subtracting. The denominator here, that's the difference of two squares. You need to be able to recognize those. If you need help with that, look at my video on the difference of two squares. Now we need to find a least common denominator. I need an x plus 2 term in both. I need an x minus 2 term in both. And an x plus 2, I already have that, so I do not need to put it in again. So I need to look at this fraction. What did I do to this fraction to get this? So it had an x plus 2. I multiplied the bottom by x minus 2. So I need to multiply the top by x minus 2. Then I have an x minus 1 here, and the denominator stays the same. So now this becomes 2x minus 4 over x plus 2 times x minus 2 minus x minus 1 over x plus 2x minus 2. Now I can write this as one fraction. Two x minus x is an x. Negative 4 plus 1. Negative 4 plus 1 is a negative 3. Can't reduce that, so that ends up being our fraction. So I hope you learned something from this, and we will see you again on our next episode. Thanks.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.